Okay, let us now talk about the first, discriminant. Let us talk about the term which is called the discriminant. When you say discriminant, it is simply part of this particular equation, the quadratic formula, which is x is equal to negative b plus and minus the square root of b squared minus 4ac all over 2a. If we go back with the previous lesson, this equation is what we call the quadratic formula. And when you say discriminant, it is simply the expression found inside the square root. Again, the discriminant is the expression found inside the square root, and that is b squared minus 4ac. That is what we call the discriminant. Now, what is the purpose of that expression or the discriminant? Discriminant will tell us the characteristics of the roots because of the fact that it is found inside the square root. If the discriminant is 0, positive, negative, it will tell us what kind of roots the equation have. Okay, so to find the discriminant, we simply need to use b squared minus 4ac. Now, there are 4 characteristics of the roots, or the nature of the roots can be classified into 4. Let us talk about the first characteristic. Okay, let's say, for example, this particular equation. Okay, the equation is x squared minus 2x plus 1 equals 0. This equation is quadratic because there is a term with x squared, the first one, x squared, and then we have the value of b, which is negative 2, the value of c is 1. So a is 1, b is negative 2, c is 1. Now, we need these 3 values to be able to find the discriminant. Use the formula for discriminant, which is b squared minus 4ac. Now, replace b with negative 2, then squared, minus 4 times, replace a with 1, replace c with 1. Solve. When you square negative 2, it means negative 2 times negative 2. The result is positive 4. And then negative 4 times 1 is negative 4 times 1, negative 4. 4 minus 4, 0. Therefore, the discriminant here is 0. So in this example, discriminant here is 0. Now, if the discriminant is 0, the nature of the roots will be real, rational, equal. Okay, so we are looking for 2 roots which are both real numbers, they are rational, and they are equal. And those roots are 1 and 1. Okay, there are still 2 roots, and both of them are real numbers, and they are equal. They become equal because the discriminant is 0. That is the first nature of the roots based on the discriminant. Now let us move to the second. This time, we have an example which is x squared minus x minus 6 is equal to 0. Same, we need to find the values of a, b, and c. In this example, a is 1, b is negative 1, c is negative 6. Replace them in the formula for discriminant. So b will become negative 1, square that, minus 4. 4 is constant, a is still 1, c is negative 6. Solve the expression. We have negative 1 times negative 1, positive 1. 4, which is negative, times 1, negative 4. Negative 4 times negative 6 is positive 24. And add 1 plus 24, the result is 25. The discriminant here is 25. 25 is greater than 0 because it is positive. And it is a perfect square because we all know that 5 times 5 is 25. Now, if the discriminant is positive or greater than 0 and it is a perfect square, we're looking for the roots which are real, rational, and equal. Okay, real numbers, and they are rational, but they are unequal, or different. Unlike the first one, if the discriminant is 0, we're looking for equal roots. In the second case, if you got a discriminant which is positive, perfect square, we're looking for two roots which are real, rational, but unequal. That is the second characteristic of the roots based on the discriminant. Let us move to the third type. Example, we have the equation x squared minus x minus 4 equals 0. This time we have a is 1, b negative 1, c negative 4. Replace them in the expression. We obtained 1 plus 16. 1 plus 16 is 17. 17 is positive number or greater than 0, but it is not a perfect square. So the difference of the third compared with the second is that the third is not a perfect square. Meaning 17, for example, cannot find one number multiplied by itself. There's up to 17. Unlike in the second case, we have 25. 25 is a perfect square. So if the case is, it is not a perfect square, your roots will be real, irrational, unequal. And I say irrational number, it means it, it is an expression wherein there is a radical which cannot be simplified or be written outside the radical sign. For example, in this case, we have 1 plus the square root of 17 all over 2, and then 1 minus square root of 17 all over 2. That means irrational. It cannot be simplified as a whole number. It can only be written as a square root. You cannot extract it anymore outside the square root. And it is unequal because one is positive here, the other one is negative. And now let us move to the last, the fourth characteristic. We have this one, example. We have the equation x squared minus x plus 4 equals 0, the quadratic equation. 1 is the value of a, b negative 1, c 4. Replace them in the expression b squared minus 4ac. The result is a negative number, negative 15. It was obtained because negative 1 times negative 1, positive 1. But here, negative 4 times 1 is negative 4 times 4, negative 16. Therefore, the result is a negative number, negative 15. Now, if the result of the discriminant is less than 0, or in short, a negative number, we are expecting that the roots are not real or imaginary roots. Okay, makita mo, you will determine if it is an imaginary number by simply looking at the number inside the radical sign. In this case, for example, the number inside the radical sign is negative 15. If there's a negative number inside the radical sign, it is called imaginary number. Because you cannot extract as the square root of a negative number. It will become imaginary number. Okay, so those are the four. Those are the four characteristics of roots based on discriminant. Okay, let us move to some other examples about the discriminant. Let's have this one. Okay, this one. Blank ano pa siya. I will show you one by one, step by step, how discriminant is solved. And after that, we will determine the nature of the roots. Okay, we have this equation. 3x squared minus 5x is equal to negative 4. The given equation. Let us first write it in standard form so that we can determine the values of a, b, and c. It will become positive 4 equals 0. So we have the standard form of the equation as 3x squared minus 5x plus 4 equals 0. Now, in this case, we can determine that a is 3 and then b is equal to negative 5 and c is equal to positive 4. So these are the three values of a, b, and c respectively, 3, negative 5, 4. With these three values, we can now replace them in the in the discriminant formula, which is b squared minus 4ac. Now, we will replace the values of A, B, and C. Let us begin with the value of B. -5 will be the value of B. 4 is constant, so do not replace it. A will become 3. C will become +4. And then continue solving. We can now square -5. -5 times -5 is +25. And then we need to multiply -4 and 3. -4 times 3 is -12. The -12 times 4 equals 48. -12 times +4 is equal to 48. So we need to subtract 25 minus 48. The result is a negative number. The result is a negative number. -23. The result is -23. Okay. Since the result is a negative number, in what particular case it will fall? First, second, third, or fourth? Case number 4. Correct, Jumel. Okay. It will fall in the fourth case, which states that the nature of the roots is imaginary or not real, or we can simply state the roots are unreal or imaginary. We're able to arrive at the statement that the roots are unreal or imaginary because we obtained a discriminant which is negative number or less than 0. That's why we can say that the roots are unreal. Okay? Let us try another. This one. This is number 10 in your book. Which activity should be answered in your weekly home learning plan? Is it activity 7, page 62? Activity 9. Activity 9, page 63. Activity 9, page 63. Item number, which item? All of these items? 1 to 5? A to D. Only. Okay? No need to answer page 64. So, ang instruction lang is to answer activity 9 in page 63. So, let me show you an example of number 10 dito sa page 62. We have 3x squared minus 2x minus 5 equals 0. Let us do the same. The way we solve this one, the previous one. This time we have the equation 3x squared minus 2x minus 5. Therefore, the value of b here will be -2. The value of c is -5. Let us now solve for the discriminant. We start with the value of b, which is -2, followed by -4 times 3 times -5. So we have to square -2, 4. And then once we multiply -4 times 3, -12. -12 times -5 will give us positive answer, positive 64. Positive 64. Ay, 60, sorry, positive 60, sorry. 64 yung sa last. Or you can simply take a look at the two numbers. Both of them are negative. So we expect that the product is positive because we are multiplying two negative numbers, -60, and then a positive 60. And then finally, we need to add 60 and 4. The result is 64. Okay, what case? In what case will this fall? Is it case number, okay, correct, case number 2. Case number 2. And that states, that particular case states that the roots are real numbers, rational, and unequal. So the roots are real, rational, and unequal because the discriminant is greater than 0 or positive number and a perfect square. 64 is greater than 0 and it is also a perfect square. Therefore, the roots will be real, rational, and unequal. Okay na? Any questions with the first lesson about discriminant? About discriminant? Any questions? Now, before we move to the next lesson, allow me to summarize first the lesson about discriminant, the summary. Let us use a table. Okay. Here, I will write discriminant and then nature of the roots. Okay, so the first one, the first case, case number 1, is when the discriminant is 0. So if the discriminant is 0, we expect that the nature of the roots will be real, rational, equal. Okay? So if we computed and then the result of the discriminant is 0, we expect that the roots are real, rational, equal. For the second case, if it is greater than 0, when you say greater than 0, it is positive and perfect square. The roots are real, rational, and equal. Case number 3. If the discriminant is greater than 0 again, meaning positive number, but not perfect square. The roots are still real, but irrational, unequal. And then finally, we have the fourth case, case number 4. If the discriminant is less than 0, when you say less than 0, it is a negative number. We expect that the roots are unreal or not real, unreal or imaginary roots. Okay, so this table will summarize the first lesson about the discriminant.